Okay, so today we're going to be talking about the reciprocals of sine and cosine. What is secant the reciprocal of?
Cosine.
Which one?
Cosine.
Cosine. Secant is 1 over cosine x. So, to figure this out, what I am going to do is I am going to take all of these values and do what? Flip them. So, I'm just going to start filling this chart out like that. My x is 0. Up top, it's 0, 0. What's the reciprocal of 0? Why do we have 0, 0 up here? Goodness gracious. It is 0, 1. I was just reading what was up top. Nobody corrected me that day. Man. Alright, what's the reciprocal of 1? 1. So it is still going to be 0, 1. Thank you. Alright, and then I'm going to skip 2 and go to pi over 3. Up top, it's pi over 3, 1/2. So the reciprocal is 2. Where is pi over 3 on here? Of pi over 2. It's right before pi over 2. So that's going to be 2. And then pi over 2 up top is 0. What's the reciprocal of 0? Undefined. So what am I going to graph for that? An asymptote. Then we have 2 pi over 3, which is the reciprocal of negative 1/2 is negative 2. Then pi is at negative 1. What's the reciprocal of negative 1? Negative 1. And I'm just going to do that for all of these. Do the reciprocals. And plot them. Do y'all agree secant is the reciprocal of cosine? When we actually, I know for this purpose we didn't, but when we're actually graphing these in just a little bit with their transformations, I'm going to have you graph the cosine function. So really quickly, I am just going to slightly shade in my cosine function here. You're not going to highlight it because it's not the answer. Whoa, I went way over right there. You're not going to highlight it because it's not my answer, but I do want you to know that you can use it to get your final answer here. So I just graphed my parent cosine function real quick. And then to get the reciprocal, you are basically going to kind of flip these curves. So do you see how this right here goes down? Everybody look up real quick. Do y'all see how this is going down right here? So the reciprocal is going to go up and get close to the asymptote without touching it. Same thing right here. This one's going down. The reciprocal is going to go up. Look up. Do you see how this is like a U shape? So This is my secant parent function. What questions do I have? Now, if I were to go in Desmos and show you the secant parent function, this is what it looks like. Is that what your graph looks like? No, your graph actually starts at the y-axis, so it's broken just into one period, which is why it kind of stops right here. But do you see how it has curves alternating?
Yeah.
Okay, so I'm going to go ahead and graph the rest of them on here. Where are my asymptotes always going to be? Pi over 2s. I'm going to draw asymptotes. And my curves for this parent function without transformations are always going to be at 1 and -1. Please make sure your curves are not pointy. And then they alternate. If it's down one period, then it's up the next period, and vice versa. Are we missing anybody? No. All right, what is my domain here? X such that x is not equal to what? Where there no x is going to be? The pi over 2's. Why the pi over 2's? Because that's where my asymptotes are. If you can fill out the domain, you can fill out the asymptote. What are my zeros? What? What'd you say? None. There isn't any. Alright, and that should help you too whenever you get to drawing these graphs on your own and you're like, oh, which way do I draw the curve? Just remember, unless you're shifting up or down, it should not have any zeros. Okay. What's the period going to be? We are back to, no, that's only for tangent and cotangent. So what's the period? 2 pi. Sorry if that's what you said. All I heard was the pi. Now my range on this is a little different than any of the ranges we've done. What's the range going to be? Low to high. What's the lowest it goes? Negative infinity. You have to have a parentheses, negative infinity. Then it goes up to what? -1. Bracket. And then it does what? Union. Jumps to 1, and then it goes to... Does everybody in here understand how I got that range? Negative infinity to 1, stops, it jumps, 1 to positive infinity. And then what's the y-intercept? Questions about secant? Not secant, yeah, secant. We're okay? Everybody's okay with that? Turn your paper over when you're ready. Go to page 2. We're going to do cosecant. Are you guys okay? I'm going to be lazy. Are y'all okay with me being a little lazy?
Yes.
Are you okay with me not filling in the table?
Yes.
You prefer it?
Yes.
Because we're not really going to use a table in general. All right, I'm just going to go straight to cosecant. So how do I do this without a table? Well, what do we know about cosecant? Well, what do we know about cosecant, though? It's the reciprocal of sine. So put 1 over sine of x. I want you to graph your parent function for sine real quick, because that's going to guide you here. Charlie said it starts at 0, 0, then goes to pi over 2, 1, then pi, 0, 3 pi over 2, and 2 pi. Cool. And I'm just going to lightly trace that parent function. How do I graph the cosecant function then? I got to do the reciprocal of every y value. What's this y value? Undefined. Well, it's 0. What's the reciprocal of 0? Undefined. So what am I drawing? Asymptote. At all of the what? All the zeros, you can just draw an asymptote. At all the zeros, you can just draw an asymptote. Remember, make that asymptote on the y-axis. Make sure it's known. It's obvious there's an asymptote there. What about the rest of this? How am I going to graph the rest of this? What's the reciprocal of 1? 1. So that point's going to stay there. What am I going to do to this curve, though? Flip it and go up. What am I going to do to the other curve? Go down. This is how I'm going to expect you to graph your secant and cosecant functions. If you can graph sine and cosine, which you've just had 3 quizzes on, you can graph secant and cosecant. You just draw asymptotes on the zeros and then flip your curves. Now, some of you are like, but Miss Olivares, what about the 2? What about the negative 2? Do I have to be precise? How wide do I make this curve? I'm not going to be particular about it. However, asymptotes are approached but never touched. Please don't make your curve like this, like super. You're trying to get towards the acid. You know what I'm saying? Okay, so just be careful. And you must have arrows on these curves. Please make sure they don't look like parabolas, meaning pointy. Please make sure they look like curves. Again, this is what they look like in Desmos, just to give you an idea of what the curve should look like. Versus a parabola looks like just a little bit. You see how it goes out super wide, like a little steeper? So long since you've seen a parabola? Oh, we have a whole unit on parabolas. So kind of see the difference, but that's in the fall, in the spring. Kind of see the difference between it's more curvy. Again, I'm not going to sit here but it needs to be curvy, not pointy. Okay? This is cosecant. Oh, secant and cosecant are just shifts of each other, but where's cosecant? Is that cosecant? Right there. There you go. It's just shifted, right? Okay. So let's look at the bottom part. What is our domain? Oh, wait, real quick. I'm going to draw the rest of them. Where are my asymptotes going to be? Pi's. And how do I know where my curves are? They just alternate from 1 and -1. Okay, what is my domain? Sorry, y'all started to say it and I stopped you. I'm going to say n pi. I wouldn't count it wrong if you wrote pi in. And remember, if you have the domain, you have your asymptotes. What are my zeros? None. And the period? 2 pi. What is the range? Negative infinity to what? -1. Union. And remember, infinity and negative infinity should always have parentheses around them, because they are not an exact number. What is my y-intercept for cosecant? Why not? There's an asymptote there. What questions can I answer? Again, secant and cosecant, you're just graphing sine and cosine first. So if you're done writing that, flip over to page 9. Tomorrow's quiz is going to be on writing equations and then graphing sine, cosine, tangent, and cotangent. Cotangent. All right, page 9. We are going to do the 4 examples, and then we'll see if you can come up with that last one yourself. All right. The cosecant of 2x. What is cosecant the reciprocal of? I want you to graph the sine of 2x. How do I graph the sine of 2x? It's been a hot minute. New period. How do we find the new period? Or why are we doing the new period? Because it's a b value. So my new period is 2 pi over b. 2 pi over 2 is pi. So I'm going to label to pi. What function is this that we're graphing? Sine. So it starts at, ends at pi 0, and has a 0 in the middle. Where is it going to go up to 1 at? Pi over 4. And negative 1 will go 3 pi over 4. And I'm just going to lightly sketch that. So how do I graph this? What would you graph first? Asymptotes where?
Zero.
At the zeros. Again, make sure I can see you have an asymptote there. At 1, what am I going to do? Curve up. And at negative 1, curve down. And what is the range? Union 1 to infinity. I'm sorry, say that again. Because the air, no, as long as you're not a specific point there, you're good. I want you to try to do the next one on your own. Go. What are you going to graph first? Negative 2 cosine x. Graph that and then see what you got. It's only, I think it's 16 minutes is what I need. So you come during lunch or tutorial. Just don't forget. Is that the cosine function y'all graphed? Do I have any questions about what I graphed, why I graphed it that way? What do I do now? Graph your asymptotes. Asymptotes are where? Where the zeros are at your pi over 2's. And then how do I graph my curves for this one? Because it's a little bit different. Say it again. Opposite. Just kind of like reflect it. Your asymptote needs to be further than your arrows, if that makes sense. Your arrows should never be like above your asymptote. Y'all get me on that? And then what's my range this time? Oh, by the way, no b, so it's just 2 pi. Negative infinity to negative 2, bracket, union with bracket 2 to positive infinity. What questions can I answer? We're okay?
Yes.
Press number be still. Alright. For this next one, cosecant. Edwin, you with me over there? Coach Dyer's right here. Coach Dyer? He wants you? Head up, write it down. Alright. Cosecant of x plus pi over 2 is the reciprocal of what? Sine of x plus pi over 2. So graph sine plus x plus pi over 2. What does that do? It's going to shift it left how many? Left 3 squares. Bless you. Oh, gotta do the y-axis. So I did the parent function, and now I'm going to move each point left 3 squares. There's no b here, so my period is still 2 pi. And now what? Draw your asymptotes. Remember, cosecant has 3 asymptotes because sine has 3 zeros. That's a little too pointy. And then flip your curves. making me tired today. It's quiet in here.
Because we're tired.
Yeah, they're tired. Today's Wednesday? It's Wednesday? Dang. I was hoping it was Thursday.
Such a Friday feeling.
Look, I would exchange. I would take 1 month of summer. Just one. If every week was a 4-day week. My best friend, she teaches in Corpus. She has 1 month of summer, but they get every 6 weeks off. And in the winter, they get a whole month off. So they get off from when we get off till Martin Luther King Day. And then they get off every 6 weeks. So like she gets to go on, they call it intermission. She just had an intermission like 2 weeks ago, got the whole week off.
6 weeks, like how long?
Huh?
Like every 6 weeks.
Every 6 weeks they get 1 week off. Huh? Science says you don't. Science says you forget more in the 3 months time than you do in that time. But they won't take it because they need money, capitalism, tourism. They won't do it.
Think about it. 3-day week and then a 2-week summer.
3-day weeks and a 2-week summer? Ooh, I don't know about that. I don't think
That's fire.
y'all would really forget every week. That's fire. I like the 4-day week 1 month. I would take it in a heartbeat. 2-day week, no. Okay, this last example that we're doing is kind of a special case. Not that it's super, super different, but I do need to note one thing for y'all. So please do not go ahead because you might mess up. Y equals secant x plus 1. Did you say oops? What do I want you to graph then?
Cosine plus 1.
Cosine x plus 1, which means you're doing what? Shifting up 1. So can everybody please graph cosine of x plus 1 and then stop? And remember, going up 1, what are you actually doing? Go up 2 squares. Can y'all give me a thumbs up when you get here? So I know you're ready to move on. Ooh.
I said that to Stratford and they got scared.
What do you do? What? Tennis, okay. Alright, are we all good? Okay, so in the past, what have I told you to do next?
Graph the asymptote.
Graph the asymptotes where?
At the 0.
At the zeros. Now, pause real quick. This 0 is not where I want you to graph an asymptote. Why?
Because it's not.
Because it's only one of them, right? So I need you to graph the asymptotes at what your original zeros would be. Meaning, where's your midline here? Where does this cross the midline? Do you agree we went up 1 at here?
Yeah.
So I want you to graph the asymptotes where your cosine intersects your midline. All these other ones, our midline was the x-axis. We just graphed them on the zeros. Whenever you shift up and down, your asymptotes are no longer the zeros. They're wherever the midline's at. Wherever the function crosses the midline. What's up? Yeah, let me say that one more time. Anytime you have a d value and you're adding and subtracting, moving up and down, that's going to change where your zeros are, right? So Find the midline. It's whatever your d value is. The middle of the function. Wherever your cosine or sine function crosses there, that's where you graph your asymptotes. So my asymptotes are at pi over 2 and 3 pi over 2. I understand that there's a 0 at pi, but that's not one of my original zeros. And then you can still reflect everything else. But you should always have 2 asymptotes for secant and 3 asymptotes for cosecant. What is my range going to be? Negative infinity to 0, union with, what's it jump to? 2 to positive infinity. What questions do I have? Alright, I would like you to try the next problem. I'm going to give you about a song. Let's see if you can come up with a cosine equation and a sine equation for this next problem. Go. Can I move this? Are y'all good? Come up with a cosine equation and a sine equation for this problem.
This is supposed to be easier.
I think the first one's easy. I think the second one's harder. Say it louder. Root, 0. A root is a 0. I gotta look those up.
You gotta set up a list.
Noted. Alright, let's see if you got it. The first one I'm hoping was a little bit easier, but maybe the second one was more complicated, maybe not. B, how do we find our B value? 2 pi over the new period. Remember we did that? Hey, that's what we did over here. That's what your quiz is on tomorrow. Oh yeah, go look at those pages for your quiz tomorrow. What's 2 pi divided by 4 pi? So my B is 1/2. What's my A? 2. Does everybody see how I graphed this given that information?
Yes.
Okay, so what is my equation going to be? Y equals 2 cosine 1/2 x. Does that make sense? Here's where it gets complicated. What is the cosine? No, we just answered that. What is the sine? Okay, so there's a little bit of, it is going to be y equals, this next part depends on which direction you go. Sine normally starts at what? 0, 0. So you could either do this one, or you could go back, excuse me, and you could have it come all the way over here. Which way do you want to shift, left or right? It's up to you. So I'm going to highlight the sine function. I'm going to start at 0 and go over here to this. Do y'all agree that is a sine function, what I just highlighted? Yes. What does that sine function do? Shifts which direction?
Left.
Shift left. So this is going to be 2 sine of 1/2 x plus pi. If you did, watch, this sine function, which it does exist, but it keeps going, then if you did that sine function, you would have done y equals -2 sine of 1/2 x minus pi. Because you shifted right, but when you shifted right, it became a negative. So you don't have to write both, you can write both of them down. But just know, if you shifted left, my purple one, it's the same thing except it shifts left plus pi. If you came right though, it became negative because it goes down first. That might be something you see on the assessment. Your assessment's not till next Tuesday, so we still have some practice time. We're going to have a practice day tomorrow with a quiz. On Friday, we're doing practice with another quiz. One of those quizzes might have a partner. And then on Monday is another practice day with a group.